The learning goals of this session are that you should understand the precise difference between the two kinds of polymorphism, ad hoc polymorphism and parametric polymorphism, that you should be able to declare your own type classes and instances of type classes in Haskell, that you should understand the simply typed lambda calculus and its properties and how this all relates to Haskell, and finally, that you should understand how the Hindley-Milner type system lets us describe parametric polymorphism. Now, there are two kinds of polymorphism in programming languages, and the distinction between them is due to Christopher Strachey. And one is called ad hoc polymorphism. Ad hoc polymorphism is also sometimes known as overloading. And the crucial characteristic of ad hoc polymorphism is that in ad hoc polymorphism, polymorphic functions really stand for a collection of different implementations for different uses. An example of that would be the arithmetic operations such as plus or times are implemented differently for different number types, but we write them the same way. So the plus and the times symbol are simply overloaded. So that's ad hoc polymorphism. Now, parametric polymorphism has a different notion of polymorphic functions. In parametric polymorphism, a polymorphic function is a general implementation and has a general type. And an example of that would be the append function. Append in Haskell is known as ++. We use the same implementation for appending lists, no matter if the list we're concerned with are lists of numbers or lists of tuples or lists of lists or what have you. It's the same implementation and it's got the general type. So there are these two kinds of polymorphism. Ad hoc polymorphism is a very old notion. It's been around as overloading for quite some time. Parametric polymorphism is not as old. It dates back to the work by Hindley and Milner from the 1970s. But in Haskell, these two notions are combined in a very nice way. In Haskell, ad hoc polymorphism is supported by the notion of type classes. And parametric polymorphism is supported by the Hindley-Milner system. Or rather, it's an extension of that. And the nice thing is that ad hoc polymorphism and parametric polymorphism can live together. An example of how ad hoc polymorphism and parametric polymorphism live together is something you can see in a function such as the maximum function that's in the prelude. What is its type? Well, it is given that A is a member of the type class ORD, so that's ad hoc polymorphism. Then max is a function that for any list of type A gives us an element of type A, and this bit is parametric polymorphism. So the same type has some ad hoc features and some parametric features, and that's really quite nice, and it's dealt with really well in Haskell.